Hi, everybody. Thanks for being here. It's a strange and unfamiliar feeling to see so many people in the same room, but happy that it's happening. I'll be talking today about KMP, Kotlin multiplatform for mobile developers. Just very shortly about me, my name is Enrique. I'm originally from Spain. I'm a Google developer expert on Kotlin and Android. I have a complicated relationship of residency with Vietnam, Spain, and Germany. I handle the Kotlin Weekly. If you don't know, it is a mailing list that sends on Sunday articles about the Kotlin world and summarizes everything that is happening there. This is my Twitter handle, and I'm mostly focusing on Android with Kotlin, backend with Kotlin, and iOS mostly Swift, despite this talk being of KMP. I expect that you have fun here. If you can learn at least one new thing, that's already a huge success. So let's summarize a bit KMP. I assume that most of you have already experience with it or have at least checked what this is about. Normally, with all those multi-platform frameworks, there is this initial argument, especially from the business side, that it will help us to reduce cost. I find it wrong, and it's probably better to switch it the other way around. This should be about increasing quality. We're having the same code base, so we can benefit from a few things, such as hiring will be easier, since we don't need to spread through different technology stacks. The team will understand better the code base, probably less bugs, etc. And even enable us to have a few interesting approaches in our company, doing things like, let's gonna focus on feature teams instead of focusing on platform teams. So we will not have anymore the iOS gang, the Android gang, but we can focus on learning things about our domain, things like I'll specialize on payment or whatever. And again, the one tech stack. This is a good thing considering the current state of hiring. There are a few approaches to multi-platform development. We have the proprietary platforms when we're developing for mobile, things like Xcode, Java or Kotlin. Then the hybrid HTML and JavaScript frameworks, things like PhoneGap or Cordova, that essentially take HTML and introduce us to us on the application, and the cross-platform native solutions such as Xamarin, etc. Now, why one more thing? So now we have 15 or 16, and what's the benefit of Kotlin multi-platform? Well, Kotlin is a modern language. In comparison with Java, which the first version was released in 1995, that's like 26 years ago, which is a huge time in the software world. It's a language that has been conceived as a modern one, including latest features with fast iteration cycles, a lot of touch basing with the community. In fact, Java is owned by Oracle, which is a company with an interesting business model. They generally buy companies to sue another companies and make money out of it. They have, in fact, more lawyers than developers. And at some point, somebody vandalized Wikipedia and added Oracle as the largest law firm by revenue. Kotlin is a different story. It's been developed by JetBrains, which is a company that you will know. It provides a really nice interoperability with Java. We have something like the Kotlin transformer as well that allows us to transform Java code into Kotlin with relative efficiency. A lot of community support. Many libraries are being developed by the community, conferences, events. This is also part of the ecosystem of language and a technology stack. And of course, JetBrains provides a top-notch tooling. It is the same company that developed Appcode. And for the record, until very recently, Xcode could not refactor Swift, whereas Appcode was able to refactor Swift. So they know what they do. As well, sharing is something optional. You don't need to commit to do KMP or your entire code base. You can do it on different modules, different features, etc. It's not a sort of a life-death commitment as you have with other frameworks. So this initially got developed, or the prototype for what is now today Kotlin native, or Kotlin multi-platform was Kotlin Anywhere. Some people at JetBrains realized that some code that is running on the server, then it gets compiled into Android and then also in the browser, so maybe there are some commonalities here. They end up with a model like this. With Kotlin native or KMP, you'll have something like a common module, and then we have particular modules for each platform that we want to implement. since this is mobile, we can focus on the mobile aspect. We will have the JVM module and the native module, and I put here JavaScript a little bit differently since the process is not exactly compilation. In the case of the iOS developers, this will get compiled into an iOS framework that our iOS developer can integrate into their Xcode project and start using this code. And in the case of the Android developers, this will get, we will generate a klib or a sort of a jar file that gets integrated into our project, and then our Android dev will have access to the code base in Kotlin native. Now, you see that sometimes people refer to Kotlin native or KMP or KMM. Are those synonyms? What do they mean? Well, Kotlin native, as per the definition from JetBrains, is the set of tools that let us compile code down to a binary that works on native. And Kotlin multiplatform is the language level for building Kotlin for multiple platforms. And KMM would be the mobile focus one, Kotlin mobile multiplatform. So it's a bit confusing, maybe, so you'll probably find all those three concepts being referred at the same time. KMP. This is about sharing the architecture, actually, not UI. We have other frameworks for that. The problem is that shared UI is a mess. Google does not care about the iOS in Apple. Apple does not care about the UI in Google. In fact, sometimes there are different patterns, and they cannot always translate 100% to each other platform. But if you think about that, everything underneath the UI is the same for most of the mobile apps. We will have a client that is executing an HTTP request against one server. It's going to take some data in JSON format. It's going to process this and store it on a database. That happens. It's going to be the same in both platforms. So that's maybe the part that we can abstract and generalize. Some technicalities. Kotlin native uses LVM, this collection of compiler and toolchain technologies developed by Chris Lattner, who was working at Apple and then later Tesla, I think. It provides runtime warranties, so things like exceptions and memory management. And it can interoperate with C and Objective-C, and with Swift via Objective-C. And this will be important later, because Objective-C and Swift have different features and limitations. We have a few platform libraries, such as POSIX, Apple frameworks, Win32, etc. The process is fairly rational. We will have our KT source file. This goes into a Kotlin compiler that creates an intermediate representation. And through the LLVM, we will create the platform finery we want. The compiler itself serves frontend with Kotlin JVM and Kotlin JS, and it has been funnily written in Java and Kotlin and used, as mentioned, the LLVM. Memory management. We're using the ARC with cycle collector. If any of you develop or is developing Objective-C, you might be familiar with this mechanism where we need to increase the usage of memory, etc. But if we're working with pure Kotlin, we don't need to worry about this. Weak references are supported, and there is a memory sharing model with different threads that can have these join object graphs, and immutable objects can be shared, sort of a super immutable object that we will see later. As mentioned, we can interoperate. We can do it with C and Objective-C and Swift, which means practically that Kotlin can call C and Objective-C classes, and the other way around. And Kotlin can extend Objective-C classes and the other way around. Mapping. We have different things in Objective-C and Swift and Kotlin. There is generally a direct equivalent between them. So more or less numbers, integers are integers, strings are strings, the gRPC entities are auto-generated, and generally the object-oriented concepts have an equivalent between Kotlin and Objective-C. So classes are classes, protocols, interfaces, and blocks, lambdas. There is this table. If you Google mapping Kotlin native, you'll see exactly what's the equivalent between all those three languages that are more representative for mobile developers. Yeah, the only thing you see is the NS number, and the suspend functions do not have an equivalent on Objective-C. But yeah, otherwise, we have a very clear mapping between them. And we have some functionality for creating libraries. Essentially, we can create our own klib files, which will hold the bytecode and some metadata, things like which compiler version I use, or when this was compiled, etc. And yeah, we can easily create our custom libraries. Now, let's gonna start seeing some examples. So we use a combination of the expect and actual keyword in order to define what needs, what is going to be implemented into the particular platform models. The expected declaration goes into the common model, and the counterpart actual will always have the same fully qualified name, return type, parameters, etc. The expected declaration is marked with expect. The actual declaration is marked with actual. And this would be the full example. You see that we have an expected class. See that there is no implementation code. It just defines the signature and what that class should contain. And this would be the actual implementation. You see that we use the actual keyword at the start, and then this is where we implement the particular logic. But full examples are very boring. Let's see something that we will end up doing. A log library. Everybody writes a log library. We have a lot of log libraries for every single platform that we use. And generally, they have these commonalities. We have different levels of logging, debug, warn, and error. And then based on this, we can decide to put a different color on the screen or whatever. So see that here we have the expect write log message, and then the enum class with the different level mechanisms. Well, this is how we would do it on the GPN. We would call, for example, print line or system out print line, or we could use any other library that we want. And in JavaScript, we will have something like this console object, is the console object from JavaScript. We have a few others like document, window, etc. And based on the debug log that has been of the log level that has been specified, we will call one method or a different one. Now, iOS and Android, since this is about mobile. Very similar. The interesting thing is that, of course, in Android, we might want to import JVM libraries, and in iOS, we might want to import iOS libraries. So another thing that we might end up doing, implementing a UID function. The common will contain the expect keyword and define the signature. And we can see that in Android, we are actually importing the Java util, and in iOS, we are importing the foundation kit. Then that way we can implement on each platform using the particularities and libraries that this platform will offer. Talking about libraries, there are a few main actors engaged in developing KMP ecosystem. JetBrains is an obvious one. TouchLab, I think, has been doing a lot of great stuff. It's a company based in New York. They organize Detroit to New York as well, and Square. I'm deliberately not including Google here, since they don't really have that much focus in Kotlin multiplatform at the moment. And if you ask yourself, well, what are the things that I can right now do with KMP? Well, you have things such as SQLDelite for an SQLite model facilitation library, multi-platform settings, stately, OKIO2. So there are already things that are productive and that are being used. And from the side of JetBrains, which is the proposal of the technology, we have things like Ktor, coroutines, Kotlin XIO, and Atomic FU. Ktor, it's a library that provides a client and server mechanism, and well, sort of a DSL for web apps. And in the client side, they provide us with multi-platform support. How would we do it? We would need to include the particular package implementation that we want. In this case, you can see that we are implementing Android or iOS. And it would work like this. We could have an application API. It would be this class over here on the common module. We're trying to connect to this overemployed.com website where they offer fantastic tips to have 5 jobs at one time. And then we get the content from there. So how can we do this now on the Android side or iOS side? So on the Android side, generally we will have a text view where we paint the content of this API. And you can see that here we call the application API class that we had before about, and when we get this content, we just add it to the text view. Whereas on the JavaScript side of things, we will have the document object similar to the console object we had before, where we can operate fully with our website. We can create a new element, we can add the content there, we can append the child, etc. And yeah, of course, in iOS, we will do something similar. We will call the application API class, the about method, and then we will just add the content, the text to the content of our text component. Coroutines, you probably know them if you're Android developers, works very similarly. you need to add the common or native packages. And then you would have on the actual implementation a method that launches the coroutine, and you would need to call it from these actual KP.show-hello coroutines. If you, this works this way because when we are compiling in Kotlin, we take the file name, generate it with a camel case convention, and then we can call static methods just specifying the signature there. So you can actually change that with an annotation if you don't like the name of the file or the class that is being generated. Kotlin X IO for primitive building and manipulation. Same thing, you just can include the latest version. And well, we'll have a byte read packet, which is a packet that consists of a managed sequence of buffer views. It's read-only, and every buffer view will be released when it becomes empty. There is a explicit release function to discard all bytes, and then we have a build functions that creates the bit read packet instance and resets the builder state to the initial one. Atomic FU for atomic operations in Kotlin. One thing is that in KMP, we don't have 3D primitives, so things like synchronized, volatile, so it's recommended to use atomic FU from the side of JetBrains. We can declare a top variable for a log-free stack implementation, so here we see this top declared on the top side and being used on the bottom side. And then we have things like high-level, for high-level updates, such as update and get, or get and update, etc. SQL Liter from TouchLab is the evolution of another library called NarchDB that has been deprecated and well, provide us low-level access to SQL. There are 4 basic interactions that we can have: insert, update and delete, execute, and select. If we need binding, we can do it through a lambda, as you can see here. Selects do not actually return a return set, and this is to avoid leaking SQLite statements. Instead, you can provide a lambda and an iterator, and then see what this select is actually returning. Share preferences, same multi-platform settings, same as share preferences on Android, and manage user defaults, really straightforward, so we just can put and save primitive values. And last, the Kotlin serialization. So this is used obviously to do deserialize and serialize values on JSON when something is coming from web service, for instance, and it's also pretty straightforward how it works. We can take a class that exists and serialize JSON that is coming into this class, etc. Some considerations. When we're working with Kotlin native, an object belongs to one single thread. How can you share this object between different threads? So there is a .freeze operation that freezes the object and creates sort of a super immutable object. Then that object is frozen, is immutable, all the references are immutable, and then we can multi-thread this object. Yeah, if you think about it, I don't think that's a concept that exists anywhere. So if you are asking yourself, did I ever freeze an object, or did I ever do something different or something similar in any other technology? I think probably not. That's, in my opinion, quite new. And yeah, as mentioned before, KMP can also verify same mutability. Now, I would like to give some tips for, or some considerations when developing for iOS. Who has experience here on iOS, just to get some grasp of? Okay. Well, take a look at this view model. That's, something fairly simple, right? We have a few generics. This could be used for login. And we have things like, a username and a password, nothing too strange. So, if you open this some time ago in Xcode, you would see that the generic cannot be inferred. And that's quite inconvenient, right? Because you don't have access to the code, and there is a generic which is like, you probably are doing generics on your second day of coding. And yeah, it's something that was bad, right? This was fixed by Kevin Galligan in like a couple of years ago. Still, 2 years is a long period of time, right? And things have changed massively. But this is the sort of things that sometimes you find when you are working with Kotlin multi-platform on the iOS side. There is also no support for multi-threaded coroutines. There is an open PR on the repository on GitHub where there is like a huge discussion of when to add it or not, but currently there is no support. So let's talk about more limitations for iOS developers. Exhaustive enums. And you will say, well, but Swift has exhaustive enums, or, well, it doesn't matter. The interoperability happens through Objective-C. That's everything that matters. So if something is not supported by Objective-C, is not supported by Kotlin multiplatform or not usable. Enums in Kotlin are reference type. It's sort of a special class. And in Objective-C, they are integers. So it's not that you can't really switch them immediately from one side or the other. The Swift compiler doesn't know what is happening. There happens to be a finite number of instances. Kotlin does it, so it does not work. Same for default arguments. Again, but Swift supports default arguments. Yes, but Objective-C doesn't. That's everything that matters for a comparison. So you might end up, let's going to go back to our logger class that we implemented before. We can see that, well, we're logging, our app has a lot of problems, so by default, this is going to be an error, log level, as it should be. And we have this class that receives this default parameter. But, again, it does not work on Swift, because we're compiling through Objective-C. That means that every time we are calling this object from Swift, we will need to specify what has been called a default parameter. Is not default anymore. And Codable. If you use, you probably use Codable as Swift developers. It's a nice sort of a serializable in Java and Kotlin. Well, there is still no support, so you can benefit from using Codable on Kotlin native since it is not supported. That has been, in my experience, my biggest concern when introducing KMP on a code base. If you happen to have a team of iOS developers, and at the end we know that there are small silos that might happen in companies when you're developing, is the part that needs to be convinced or somehow pushed into this technology. You're putting new members or confronting new members into a different technology stack that they're used to, and there might be some resilience and resistance there. The strategy will depend a lot on your company and the team and the management and many other variables, but keep this in consideration. It's going to be an obstacle, or it might be an obstacle when you're talking about adopting KMP. Architecture. How should we architecture KMP apps? Well, luckily, it's not that hard. In fact, it's fairly similar to what you have been doing on other platforms. There is this article here from Javier Arroyo, if you Google multiplatform MVVM clean architecture, that you can use to see how you could architect something. But essentially, I think probably the discussion is about what do we want to move into the KMP side of things rather than discussing so much about an architecture. Because we can pretty much keep what we have. We'll have our Android that has activities or fragments and then view controller. And underneath, we're going to have the shared code on KMP. We can model that and have a view model, have use cases, have repositories that insert things on databases or connect to APIs and take data from there. That's not going to change significantly how you are working. And as mentioned, we have things such as SQLite and Cater. There has been recently a KMM survey from JetBrains for the two first trimesters of this year, and well, some people they were asking a few questions: how do you use it? How's your feeling? Would you recommend, etc. And I take some selection of slides here. How much share code do you estimate there is in your multi-platform project as a percentage? You can see that it might vary, but we have a significant amount of code cover, things like this 30% by 50 to 70% of the participants. So again, this is a technology that is starting. There has not been maturity enough to put an entire code base there, but I see this as a good sign. How much time did multi-platform adoption take? I think the nice thing here is that in 85% of the cases, the full adoption took less than 6 months. So that's fairly short period of time, talking about development and introducing a new technology. Normally there is like an evaluation process, etc. That I find it as well very relevant. Are you satisfied with the quality? And 99 or 98.3 of the people answering this survey said yes, which I think is a very big number. I wonder if you ask in any other frameworks how people feel, if people feel satisfied, this number is going to be very hard to reach. Are there case studies? Do you want to implement this on your apps? Do you need to argue with management or any other relevant person at your company on whether this is a nice solution for you or not? Well, we have this website here, mobile case studies KMP. You can also easily reach this through Google. And those are use cases or case studies that JetBrains has taken. They have interviewed with some people working at those companies like Philips, Netflix, Leroy Merlin, etc., that are currently using it on production. So the answer to, is Kotlin multi-platform ready for production today is probably yes. What's coming in the future? It's really hard to make predictions. Otherwise, we will all stop programming, put some money in the stock market, and quit our jobs in 3 months. There was this article written by a guy called Adrian Kowaczewski about how to be a developer after 40. And he wrote something like, I don't know what will happen in 10 years, but there will be people asking in Stack Overflow about regular expressions, and there will be another JavaScript framework, probably Angular 10 or something. So again, you cannot predict the future, and probably in 10 years there will be more multi-platform frameworks, and there will be no single standard or single source of truth. But it seems that KMP, it seems like a reasonable approach today. My colleague Juhani Lehtimäki wrote this or posted this graph somewhere, and I think it's very clear as well about the cross-platform frameworks. There are a lot of, you start making the hello world, and then you start integrating in your app, and then it makes sense, everything goes very fast, and you start adopting it. But then real projects are different. In real projects, you might be having very intense access to the hardware. You might be integrating from different APIs. You might have concurrency, etc., these sort of things. And at this point, many cross-platform frameworks hit a wall, and it's hard to keep moving with them. Unfortunately, by that time, you have your entire code base migrated, and you start having real troubles. My personal takes. Use it with caution. Unless something is fully 1.0 stable, I have also had trouble recommending it. Same thing with Compose recently. Starting adopting Compose before means breaking the API, etc. Use it on shared components, so never compromise the entirety of a project, maybe a small modularization and putting things into your experimental framework or module. Keep the versioning in mind, as mentioned. 1.0 is probably the moment where you can jump without any concerns, and never compromise 100% of your project. I would like to give you some further resources. The Kotlin Slack, if you haven't joined there yet, it's a fantastic place. Then there is these resources from TouchLab. They actually have a few really nice things. They created a mobile kit for developers that you can download and get started immediately, and one for iOS developers that provides the very basic structure for an iOS project. If you allow me some spam, the Kotlin Weekly mailing list, if you haven't subscribed yet, I promise it's good. And then the Kotlin native for KMP documentation. If you Google it, you'll reach it. And I think they have a very comprehensive documentation describing essentially everything that can be done. That's everything. Thanks for being here in person. You've been a fantastic public. And if you have any question, and I happen to know the answer to that question, I will be super glad to help you with it.